Now it's time for the sine function. So this right here is one whole cycle of the sine of y equals sine x. So how does this graph here relate to the unit circle, and how do we even get this graph? So let's do a simple example first. So let's say right here is 15 degrees. So I'll write it big first. 15 degrees. So first, before we do anything, you should know that sine equals height. So basically, I don't know if I spelled that right, but it equals a y value. So here it would be 0, 1 on a unit circle, and here it would be 0, negative 1, because this is 0 right here, up 1, down 1. So as you know, in a unit circle, the radius is 1, so 1 would be here, and sine equals opposite over hypotenuse. So we need to find this. So sine 15 equals 0, or y, we'll call it y, over 1, because the hypotenuse is 1. So the y would be equal to 0.259. That means here it would be blank, comma, 0.259. So let's look here now. Since this is 90 degrees, 15 degrees would be somewhere here, and right here is 0.259. So if we plotted every single degrees, if we did this for every degrees all the way around the unit circle, we would come with this graph. And as you can see, 90 degrees, which is right here, it's 1 on a unit circle, and negative 1, which is 270 degrees right here, negative 1. So yeah, one whole unit circle. So now let's see, are there any shortcuts? Are there? Let's find out. Let's see. So, any shortcuts? Let's do 60 degrees now. 60 degrees. So 60 degrees, sine 60 degrees equals 0.87. But right here, 120 degrees, this same place right here would be 60 degrees, so that is also 0.87. That means there's at least a value of 0.787 in every quadrant. That means right here, 240 must equal 0.87 degrees, the y value. But wait, that is wrong, because remember I told you that below this line everything is negative because this is 0, negative 1. So this needs to be negative 0.87. So now let's look, 240 here, yep, 0.87. See, it all makes sense. Everything makes sense. That means here too, right here, 330 degrees, must also be negative 0.7 because it's below this line. Everything here, the sine value must be negative. Must. Let's see if there are any more shortcuts. There's one more shortcut. So let's look. Now, let's pretend this here is a 60-degree angle. But, oh no, our calculator died. What do we do? Now you all remember this. 60 degrees, 30 degrees, and then 90. It's a 30, 60, 90 triangle. 1/2, square root 3 over 2, and 1. So sine is opposite over hypotenuse. So opposite is square root 3 over 2. So this is correct. That's the correct answer because this equals to 0.87. And if we look here, 60 would be around, 0.87. So that's the correct answer. Now let's say there's a 45. This is 45 degrees. Let's pretend. Do we recall the other one? 45, 45, 90? Those are 45, 45, and 90. This would be 1 square root 2 over 2. And then this over here would be square root 2 over 2. That means this value here, the y value must be square root 2 over 2. But as I told you before, below this, negative. So negative square root 2 over 2. So that is a very simple way if you don't have a calculator. Once we go over unit circle, there will be an even easier way to find this out, so you just have to wait. Now it's time for cosine. So this right here is one whole cosine cycle. As you can see, it comes from high, the highest point at 1, goes all the way down and all the way back up. So how does this relate to the unit circle? Well, first of all, cosine equals base. That means right here, it would be 0, 1, and here it would be negative 1, 0. So basically we can say it equals x, because that's the same thing. So let's do an example. Let's do the same degree that we used for sine. So 15 degrees. But this time, instead of finding this one here, this is sine value. This is the height, which we found the last time. This time we're looking for the base, because this is cosine. So cosine equals adjacent over hypotenuse. So cosine of 15 degrees equals to x over 1. And the answer would be x equals 0.97. So now let's look over here. Let's look. So let's 15 up here. Yay, 0.97. Just like the sine graph, if you plot every point, this is what it will look like. See, 90 degrees is 0. From 90 degrees is 0. 270, also 0. That's why here, 0, here, 0. Now, are there any shortcuts? Let's look for some shortcuts. Let's see. So, let's do cosine 30. 30 degrees. So, cosine of 30 degrees is equal to 0.87. So let's see. Over here, 150 degrees. Oops, my voice cracked because I have to drink a lot of water still. So cosine of 150 also equals 0.87, because right here this is 30. Wait, that's wrong. Remember? Blah, blah, blah. Here is 1. Here it's negative 1. So here it must be negative 0.87. Phew, almost made a mistake. So over here somewhere, blah, blah, blah. Let's say it's here. So right there, yeah, 0.87. See, yes, that's right. Now, let's see if there's any more shortcuts. I think there's one more shortcut that's the same as the sine graph shortcut. So here, 60 degrees. Oh, yes, do you remember? Yes, you do remember. 30, 60, 90. 30, 60, 90. Oops, didn't draw. Why not? So 1/2 square root 3 over 2 and 1. So what would the cosine of 60 degrees be? Yes, 1/2. That means here the x value is 1/2. So 1/2 comma blank. Yes, correct. Now let's do some examples. I'm so excited to do this example with all of you. Okay, let's do a weird number like, no, let's not actually. Let's do 30. 30 degrees. So right now we're trying to find this point if the value here was 30 degrees. So, as you all know, it's part of a 30, 60, 90 triangle. 30, 60. What's this? Square root 3 over 2. What's this? 1/2. And this is 1. So right now we need to find the cosine, which is the x value, and the sine. This is not a very good drawing, but that's the y value, because as I told you before, base, height, cosine base, sine height. So right here, this would be square root 3 over 2, comma, 1/2. Now, what would this be here if this was 30 degrees too? Na, 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 na. So whatever this would be here, which is so 120. So this value here would be 120 degrees. This must be the same. No, no, no. This time it's going this way. So here at 120, it needs to be negative square root 3 over 2 and 1/2. Now let's say it's here. This time it's going to be here. This here. So what would this have to be if it was in this quadrant? Positive square root 3 over 2 and negative 1/2. Because this time it's going here. It's here, which is less below the x-axis and on the right side of the y-axis, which is positive because, as we all know, this is 1, 0, and right here it's 0, negative 1. Yay! See, now it's not so hard. After I teach you more about the unit circle, we're going to go to harder problems, so that'll be very fun. Yay.